welcome. The main topic for today is MicroStream deep dive, and for that reason I brought 3 topics for you today. The first one is how to create proper backups with MicroStream. The second one is a topic all around lazy loading with a small example. How does it work? And let's have a look to the RAM also. And the third one is how to write data in a very high frequent way to MicroStream. And I'd like to start with the backup strategy. And as you can see here, there is still a project up and running. I prepared for some backups, and I'm gonna start with the easiest backup, in my opinion, which is also explained here in the documentation. That this is the full backup strategy. You can use that full backup manually by pushing a button, or you can even use some frameworks like Quartz to create automatic full backups, but this is up to you. The way to create a full backup is explained here in that topic in the documentation, but let's have a look to my project in Rapid Clips. So here it is. This is the project we have seen in the browser. It's still running, and what I have done so far is so this is the project. I created all that MicroStream stuff I need, and I created that main layout user file, and just for presentation I created that backup button, and here you can see the code which is needed to create a full backup. So in my case, I used that classes and methods here, and I added the backup to my hard disk, to this path. And let's have a look to this path. And here we are. And you can see there are only the normal default files inside that path. So let's click on the backup button and see what happened. Okay, let's go to the browser. You can see this is the data is still loaded, and now let's create the backup. And let's have a look to the folder again. And now you can see the folder is created. And inside that folder we have the channel files and also the persistence type dictionary. And of course now you have to take care about that backups by yourself, but this is the way to do it manually. And of course you can use Quartz as automatic framework to create or do some Java stuff. Okay, let's go to another strategy, and we call it the continuous backup. And most of the time we said also it's kind of like a mirror. So every time data is written to the storage, the same data goes to the mirror. So that means that the mirror grows in the same way that the storage grows. So yeah, let's say it's a mirror. So how to set or how to activate this mirror strategy? In this case, you have to put one line of code. It looks like this. You have to only say, okay, .set backup directory, and then you can add the path. And this is what I've done so far. So I created that for you. So I said, okay, set backup directory in user home. That's a more extended method. And I added a second subfolder to my MicroStream data package. So let's have a look when we, but for this we have to delete the storage. Again, this is the normal storage. Here is the subfolder I created for the mirror, and I will also delete this. So, and let's start again the project with the mirror strategy. I think the best practice way to use this backup strategy is to do it from the beginning. So when you create the MicroStream storage, you should also, or you should always have a Miro up and running. That is best practice, I guess. So let's have a look to my application. Okay, let's refresh, and I started the storage, and now when we have a look to the folder, we should now see that, okay, first we have the normal storage, it's here, and let's have a look to the continuous backup, and we have the same storage here. This is working good. But is this a proper way to create backups? And to be honest, I guess not. Because what happened when my hard drive was destroyed? So then the original storage is gone, and also the backups are gone because they are on the same system. So we need to find a way to write the backup to a different storage system. And in my case, I use the AWS S3 bucket, and I prepared this again, so I can deactivate this code, and I will use for further configuration this one. And this is nearly the same like the above, but in this case I use the storage configuration layer to make more or better configuration. And as you can see here, I created a class called S3 utils, and inside this class there are all that the connection things to get access to my Bitbucket instance. And yeah, this is the bucket, and I created a folder inside that bucket. Let's have a look to that AWS screen. Okay, here we are. This is the bucket called CKMS bucket, and inside that bucket I created a folder named backup demo. These are my bucket. Let's have a look later on. So let's come back to the code. Okay, this is my basic directory path here, where I write the normal storage, and this is the configuration for my backup storage. And now I am able to say, okay, set backup setup, and now I can use this backup setup here, and then I create the configuration. And with that configuration, I'm gonna start the MicroStream instance, and let's have a look if this works. Okay, I'm gonna start the server. Okay, now it's up and running. So let's have a look to the browser, refresh the application. Okay, you can see it's still empty. Let's initialize the storage, and as you can see here, it needs a little bit longer because he has to connect to the AWS instance. But here is the data, and yeah, let's have a look to the storage folder, backup demo. You can see here, this is the normal storage on my hard drive. And when we now look to the bucket, maybe I have to refresh that screen. So let's go into the backup demo, and here you can see the files which are backupped to the AWS bucket. Nearly the same structure like on my hard drive from the previous example. Really great and really easy. You can find that project on my GitHub account, which is linked in the description of that video. So let's go further to topic number 2, and this is all about lazy loading. So let's go. And I also prepared a small project for that. But before we go deeper into the code, let's have a small look to the documentation. You can find the topic lazy loading as a subtopic of the normal loading data. And the reason why we need lazy loading, it's very easy to explain. MicroStream is an in-memory data approach. So it's an in-memory database. And because of that, all the data will be loaded into the RAM during the startup of the application or of the storage. But sometimes we have data in our storage that we don't need inside the RAM all the time. So we have to define some data as lazy data, and it should the data should also should only be loaded when it's needed and not all the time. So let's have a look to the data. And in my case, the interesting part is inside that customer entity. And you can see here this line of code. But first, let's have a look to this application. At the moment, it is up and running. So let's have a look to that application. And what you can see here is I created a small amount of data here. And I uploaded a file, and this file was around 200 megabytes. And when I click on refresh, this row is loaded here to the grid. And you saw that that entity in the code, and one part of that entity was that file byte array. But let's have a look to the storage or to the RAM itself. Let's do the garbage collection. And as you can see here, the storage is loaded and also the row is visible and it's loaded, but the storage needs around 65 megabytes. That is much less than the file which is inside that row. So now let's have a look how this is done. Okay, the most important thing is that type. This is a lazy wrapper type, and within that lazy wrapper type, there is the normal data type. So it is wrapped inside that lazy. So every time the customer is loaded, this file will stays on the hard disk and will only be loaded when we click on file.get. And I prepared that in the application. So let's have a look to the main layout. There should be a button, and with that button we can load this file. Yeah, this one, load file from lazy instance. So let's go to that button event. Okay, what happened here is this point grid get the selected row, give me the value, and afterwards I call get file. So this is the lazy reference. This is not the file itself. This is only the lazy object. And I'm gonna store that lazy object to a class variable called file. But this is not, again, this is not the instance. This is the lazy instance. When I need the file itself, I have to call that get method on the lazy file. So, and when I call that get, then the file is loaded. Let's have a look to the application. So I have selected the row and I will open the RAM monitoring beside. So let's do garbage collection. Okay, we can see 65 megabytes. And now when I click on load file from lazy instance, the file will be loaded. Here you can see. Okay, very nice. But there is another interesting question. When the file will be released? And this is what we are gonna talking about in the next 10 minutes. Okay, the first way to clear the lazy instances is the manual approach. So I created a button event here, and here it is. First of all, you have to clear all the still existing references to that file. In my case, it's I called it BS. This is the file or the reference to that file.get or to the file directly. So I set this to null. This is important. Otherwise, the next line will not work. This will only work when no reference is still available. So first of all, clear the references. Afterwards, you have to call the clear method on that lazy object here, on the lazy wrapper object. So call that clear. And after that, we use that call to run the garbage collector. This is not really necessary, but so in my project, I use this to visualize this on the RAM monitoring system. So let's go to the application again and show how does it work. So you can see the application is still running, and you can also see this step here. This is where we loaded the file, and when we now click on clear lazy instance and call garbage collection, you will see that the RAM will be decreased. Yeah, as you can see here, it works great. But again, it's important to set all the references to null and then call that clear method. Okay, the second way to clear lazy references is the automatic way. You will find a subtopic here in the documentation. And by default, this check is already activated, and it checks in around 50 minutes the data, if there is any data which is no longer needed in the RAM. So, and it clears it automatically. But if you want to do it faster or in a manual way, you can define a shorter duration maybe when you use this code, for example. And in my example, in my project, I used a smaller duration just to show you how it works. So I used a duration of 5 seconds, and yeah, let's have a look. How does it work? Here we are. I started the application again. I open VisualVM, and here is the row. So, and now I'm gonna load the file from the lazy instance, and as expected here, the RAM which we needed is increased. And now let's set the references to null, and hopefully the 5 seconds now will take care about that data which is no longer needed. So when we now click on perform garbage collection, we will see that the RAM will be cleared automatically. This is also working fine. Okay, let's go to the last topic for today. This is all about the writing high frequent data to the MicroStream storage. And for that example, I've prepared just a small method inside my UI file. So let's see it here. Yes, here it is. So I created a while true loop, and inside this loop I create a new company object, as you can see here, and I added this new object to the company collection, and after that I'm gonna call the store method. And the object we stored is the collection. And when you remember, the MicroStream storage does not change any object instead of adding or appending the data again and again. So when we store that collection, then this collection will be added to the storage or will be appended to the storage again and again for every time the loop is running. And when we now click on the application, on that button inside the application here, I call it create endless companies, and we have a look to the storage. This is the channel. This is the channel file inside the storage. Then you will see that the amount of .dat files will increase dramatically. So let's have a look. Let's see what happened when we click here. Oh, and I guess I have to switch to the right project. Okay, it's still empty, but that doesn't matter. So let's create companies. So we will see the storage is initialized, and let's have a look to the channel file. And this is what I've talked about. The .dat files are increases more and more. And the reason for that is MicroStream does not change the data inside the storage. Instead of it appends data all the time. And normally there is an internal process called housekeeping, and this housekeeping takes care about all that duplicate files, and it will clean it from time to time. But now we write the data in a very high frequent way, and there is not enough time for the housekeeping process to clean up all that files. So now let's see what we can do to prevent this stuff here. So I will stop the application, and as you can see here, there is a method called set housekeeping interval in milliseconds. And that means that the interval will get 30 milliseconds to do all that stuff which is needed to clean up all that files. For more detailed information, you can have a look to the documentation of MicroStream. Yeah, there are a lot more informations in the documentation. So let's see what happened if we run with that settings and store again the data. So let's go to the application. Let's say refresh on the browser. Let's have a look to my folder here. So we can see all that files, and let's see what happened when we now start to create companies again. Okay, the storage will be initialized, and now you can see there are some more data in the end is created, but let's wait what happened. So what you can see here, that the amount of files are decreased. So there are less and less more files. So now you can see in the end, we have only 1 or 2 files which is created, and the housekeeping does its stuff very well in the end. So that's the way to write high frequent way to MicroStream storage. Okay, that's all from my side for MicroStream deep dive. I wish you happy hacking. See you in the next video. Bye bye.